Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is on section 2.5, which is if-then statements. An if-then statement is exactly what it sounds like. It's a statement that has the word if and the word then in it. So let's do an example. If you are tardy 3 times, then you will get a detention. Notice my sentence has an if in it and then in it. The hypothesis of the sentence is maybe a word you've heard in science class before, is that all of the words that come after the if. So it's the if part of the sentence, but not including the if. So our hypothesis here is you are tardy 3 times. The conclusion is the then part. It's all the words after the then. So our conclusion is you will get a detention. Deductive reasoning is basically using logic. You're using facts, properties, and definitions in a logical order. That's what math is all about. We're going to be putting things in a logical order and making sure they make sense logically. So that's the kind of reasoning we'll be doing in our head. That's kind of versus inductive reasoning. Inductive reasoning is looking at patterns. So one is using cold hard facts, and the other is using patterns. So we're going to be doing a lot of deductive reasoning in this lesson and many other lessons. We already did inductive reasoning. So the first law of logic we're going to learn is called the law of detachment. Basically, if the hypothesis of a true if-then statement is true, so if the hypothesis is true, then the conclusion is true. So let's go back up to this example. If you're tardy 3 times, you get a detention. Let's say the hypothesis is true. You're tardy 3 times. Then I know that the conclusion is true. I know you will get a detention because this is a true statement. So that should kind of make logical sense to you. It's just a law of logic that we give a name called the law of detachment. The other law of logic we're going to learn about is the law of syllogism. And we'll simplify it in a moment. If the following 2 statements are true, then the third statement is true. If statement P, then statement Q. If statement Q, then statement R. What we can do, if you see P is going to Q, and Q is going to R. So we can cut out that middle Q, and we can just go straight from P to R. So let me kind of show you in symbols here. If P goes to Q and Q goes to R, then we can cut right from P to R. That's what it's saying. Let's do an example, make this a little bit more clear. Identify the hypothesis and the conclusion. Well, the hypothesis is everything after the if. So there's your hypothesis. Do not include the if. I pass the driving test. And then the conclusion is after the then. I will get my driver's license. That's pretty straightforward for you. Example 2, now we need to turn it into an if-then statement. Rewrite as an if-then. Every game on my computer is fun to play. All right, so there's no if and there's no then in here. We need to keep this the words at the beginning, and the words at the end, So this stuff needs to stay at the beginning, but I can't just say, if every game on my computer, then is fun to play. That doesn't make logical sense. So we have to rearrange it just a little bit. If we say, if a game is on my computer, then it is fun to play. In the next one, letter B says, I will buy the CD if it costs less than $15. If you see an if, you need to use that if. And we need to take this and put it at the beginning. If it costs less than $15, well, that needs to go at the beginning, but I don't like this it here, because I don't know what it is referring to. I can't say if it costs, because I don't know what that's talking about. So this it is referring to the CD. So if a CD costs less than $15, then I will buy it. Now I can use the word it because I know that we're talking about a CD. But if I just said, if it costs less than 15, I don't know what you're talking about. So that's why we have to replace that. So if you see an if already, you need to use the if. If not, keep the words at the beginning and the words at the end at the end. The follow-up says, in a sentence that contains a hypothesis and a conclusion, is the conclusion always at the end? Explain. Well, we just did an example where the hypothesis was at the end, so this is no. In example 2b, the hypothesis was at the end. Now you get to try. Rewrite the statement as an if-then statement. All right, so that's your first. If, then. You need to write out the statement. And notice, they already gave me an if, so I need to use that. So this is a lot like example 2b that we just did. So look at example 2b if you need some help with this part. And then we need to identify the hypothesis and the conclusion. This is just like example 1. So if you need those to help you, go for it. But I want you to do this now. Make sure you replace the it there, or the it's there when you do that. Using the law of detachment. So this is our rule of logic. This is if the hypothesis is true, then the conclusion is true. So let's see here. We've got a true statement. If you wash a cotton t-shirt in hot water, then it will shrink. You wash a cotton t-shirt in hot water. So what do you know? Well, you know, since you did this, you know that it is going to shrink. Because if the hypothesis is true, then the conclusion is going to be true. That the t-shirt will shrink. All right, if x has a value of 7, then x minus 3 has a value of 11. And they're asking us, what can you conclude? Well, we know x is 7. Well, what happens if x is 7? Well, if x is 7, this is what happens. This is what we can conclude. We can conclude that 2x minus 3 has a value of 11. Because if the hypothesis is true, then the conclusion is true. So I want you to do number 3. What can you conclude? If you study at least 2 hours for the test, then you will pass the test. You study for 3 hours. So what do you know? If you study for 3 hours, what's going to happen? Go ahead and write that down. Which argument about the statement below is correct? If two angles are vertical, then they are congruent. Here's argument 1. 1 and 2 are congruent, so that means they're vertical. Here's argument number 2. 1 and 2 are vertical, so that means they're congruent. Well, if you think about it, you made a Venn diagram where we had congruent angles out here, and vertical angles were just a type of congruent angles. So if they're congruent, that means they're vertical? No, this doesn't work. But if they're vertical, that means they are in the congruent circle. This is the correct argument. And you notice it works forward. 1 and 2 are vertical. That's the very first thing here. Then they concluded the conclusion. You always want to conclude your conclusion. Argument 2 is correct. The hypothesis, which is two angles are vertical, is true, which implies that the conclusion is true. We have to work forward. We can't work backward. All right, the law of syllogism is the one that cuts out the middleman. It cuts out that middle. If you remember, P goes to Q, and Q goes to R. Then we can just cut out the middle. We can just say P goes to R. So let's give an example here. If the daily high temperature is 32 degrees or less, then the water in the pipe is frozen. If the water in the pipe is frozen, then the pipe will break. So we're kind of following the story here. If the high temperature is 32, the pipe's frozen. Well, what happens then? If the pipe's frozen, the pipe will break. So our middleman, the one that we're repeating, is this right here. We can cut that out, just like we cut Q out here. So we can cut out all that middle stuff and go right from the beginning. If the daily high temperature is 32 degrees or less, all the way to the end, then the pipe will break. For your checkpoint, you have to follow the story. If the ball is thrown, it will hit the window. If it hits the window will break. You need to combine this into one sentence, cutting out the middleman. All right, combine into one. Cutting out the phrase that's in the middle. That's what you have to do there. That's all for today. This is M Cubed signing out.